Welcome to episode 8, if I'm not mistaken, or 9. Either way, it doesn't matter. This is the second part of our entity component systems journey. And in this part, we will focus in continuing where we left off in the first part, meaning we will go and where's my pen? Seriously, I don't. Okay, it's under the graphics tablet. Here it is. So last time we mentioned that we might have that case when we have three entities, for example, and what happens when we remove this entity? We'll have those cells from each component bucket unused. And we said that we want to reuse this. So when after we delete entity number 2 and we create entity number 4, we want entity number 4 to actually use this part of the storage. So this is where we left off, and this is what we will be focusing on. Now, here in the code, I did some changes off screen, basically rewriting this add component function to please the continuous integration steps, and basically this is what he was complaining about, so I rewrote it and now it is happy. The check system is happy. And other things that went on off camera, I created the second split and I already moved those two user stories about the query system over this this storage system we are describing here. And the idea of systems that are using queries to query the components and to do stuff with them. That being said, in the current sprint, in sprint 1, this is what we worked on and this is done. This is done. It doesn't appear as complete because we did not push this commit. So this one takes care of user story number 6. And about user story number 7, we did not finalize our commit, but the bulk of the work is here. And we are dealing, yes, with adding and removing plain data objects as components. And now we go and re-enable this unit test. This unit test, if you remember, is designed to test this scenario. We have three entities at the beginning with those components, and then we delete entity number 2 and create entity number 4, and we expect entity number 4 to use this part of the storage. Okay. For this, we need to keep track between the unique entity ID and the actual index in the storage. And we mentioned last time something about an entity record. So let's go and create that. But first, let's sketch a bit more. So let's sketch here in this corner. At the beginning, we don't have any bucket allocated. So when we add a... Well, actually, you know what? Yes, at first we don't have any bucket, but the first step is to create the entities. So the first step is to create entity 1, entity 2, and so on. Then at the second step, when we add component 1, component 2, at this stage we are allocating the buckets. The two buckets, the one for components of type C1 and the other one for components of type C2. Okay, and how big this bucket is should the size of the bucket when we initialize it should be the same as the number of entities. So in this case we have two entities, so we have two chunks or cells in our bucket. Okay, and then we create the third entity, and we add another bucket here, and then we remove entity number 2. So this one, let's change the color. This one, it's considered not used. So the capacity is 3 cells, but we are using only 2 of them. Entity 4. This is 0, 1, 2 as in bucket indexes. So how can we keep track of this, of what IDs are free? I hope I'm not overthinking it. So an idea would be, at the moment when we create an entity, okay, we will allocate the not used cells in the buckets, if there is a case. And we also keep a record of entity ID to index. So we link this with this and so on. But we might be interested also in keeping a map from an index to an entity ID. Will this be helpful? Actually, we don't need this. We don't need that. Let me get rid of that. We don't need that. Actually, we need this first mapping from an entity ID to an optional index but when we remove an entity we discard the ID. No, it's not good. Well, actually it's good because we can, from this hash map that maps entity IDs to actual indices into the storage, we can ask give me the first key with the value of none, being an optional. Okay, let's try to implement this idea. Instead of entities, we will have an entity ID record, and this will be a hash map from entity ID to an optional index. We define the index up here. It's basically a new size, but I like to think about it as a different type. And maybe at some point they will be different types, actual different types. But either way, let's go ahead. Universe. So we are here in our universe. We have this entity ID record, okay, and we use this optional index. Okay, next, when we create an entity, with the old system, we just pushed the IDs into the entities buffer. Now, what we want is to query this this mapping let's try something. We have our entity records. Here we have our records, and we want to find, not to find keys. Yes, we want to iterate the keys, the current keys, and so we will go for key. The key is an entity ID. It's not good. What did I thought this is a good idea to have a mapping, because this will be ever increasing. I thought it would be good because yes, indeed, we can iterate for entity ID in the keys, and we can ask this the records dot get. We don't need it to be mutable, so we get the entity ID. What's wrong with you? Okay, whatever. We get the value for that entity ID, and actually, you know what? We can just go like this. We iterate over the keys first. Filter. Find. Okay, find. What we are finding. We look for what if no. We iterate over the keys and we are looking for with we are looking for the first key value pair where the value is set to none. Okay, and this returns an option. So we unwrap this or okay, so we'll go like this. Let reusable index but it's not good. Actually, we want them the other way around. We want a mapping from a natural index to an entity, to an optional entity ID. So we swap those. We swap that. And now our keys are our indices, sorry. So for index in self.entity ID records dot keys. Okay. Sorry about going haywire with this, but I'm picking three things at the same time. So we are finding the first one where or maybe we can go like this. Find iter dot find. Oh, come on, find. And the predicate here is the key value pair. Okay, perfect. So here we want to use index and actually we will be iterating over the keys. It's much better like that. Keys, if I can type. I hope I'm not screwing up this recording because at the same time I'm rendering the first part. I've recorded. Okay, find this, and we want self dot entity id records dot get x. Okay, is none, because we do this because when we will eliminate an entity from the storage, this one will be set to none. And because an index has no entity ID assigned to it, we can reuse the storage. That's the strategy. Okay. And here we will do like this. If let's so if we have an index, we'll do something else. Otherwise, we will just create a new cell here. Okay. Okay, so let's see. Now, when we have an index, we will go self dot records dot entry. Yes, entry. The key will be our index. That if let entry, I don't like this. If I'll modify this if Clippy will complain. If let some value. Okay. No, this is not a value. This is entity ID. Because get mutables of index. Then entity ID will be set to some ID. The ID we generated here. This is the incremental ID. And here, before we append an uninitialized component type to each bucket, we also want to go to our records, entity ID records, and insert the new generated ID, not ID, come on, index. So the index for this one will be the length plus 1. Okay, so that will be self.comp. Oh, this is quite nasty. Well, it's not nasty, but I think we will need another field here that will keep track of how many different types of no. That one will be the number of keys in our records hash table. So it will be how many indexes we have plus one. Let index equals to self dot records records dot keys dot count len. Okay, plus one. Or just the length. It's the length. We know why? Because we have 3 slots used, but the IDs are going from 0, 1 to 2. So this is the length here. Okay. Going back to the code, we have that, our new index, and we have a mapping from insert a new mapping from the index we computed here to some entity ID, to this ID. Okay. Next, when you are removing an entity, as we mentioned, but now we go to our records, we go to our records and we use an iterator and we find, what do we find? So we have this entity ID, but this is given to us. So we get an entity ID. We are given an entity ID, and from this entity ID we need to get the actual index. We get our values as mutable because we also want to mutate. Dot find position, and the predicate will be don't like this. What do we had before that? Before that we had this remove entity, this one. Okay, so the catch here, when we remove an entity and here we are checking that our x is equal to some entity ID and yes, if we found an ID, if we found this not ID, this index, when we found this index we will just go iterative visiting all values in arbitrary order. Oh, okay, so the order is not guaranteed. Because of that I can't use position here. But what I might be able to do to use find and find what will give us. Okay. It's not good. I need to rethink this one. Maybe in the end we should have an entity that stores an actual index. No, we don't want that. No, it was right at the beginning to go from an entity to an optional index. That was okay. Yes, that was okay. Now let's rethink this. So when we create an entity, we generate its new ID. We increase that one counter and then we go to the entity ID records. Okay. And we go over the keys. And the keys are the entity IDs. And we look for the first record that this is not good. This is not good. Okay, this ID. And of course, it does not exist here in the entity ID records because we've never put it there. So in this case, we actually want to retrieve this. To retrieve and this is not an option. This is I'm inspiring myself from this one, from entry. You see entry occupied and entry vacant. I think I'll just use something like that. Yes. So I'll just put an enum here. Record. Entity record. And occupied with an index. And vacant. Again with index. And we have that. And then we will have this hash map from entity ID to an entity record. An entity record, good. And here we want to find the reused index, and for that we will look into our records and find so we will find the first record where the entity record is set to unoccupied or vacant. Vacant, how do you pronounce this one? So for this one we will go again with the keys. We will go with the keys and for each key transform for each filter. Yes, we are filtering, and we will filter on what? On the fact that self.records .get, and this is X, the key. No, this is the entity ID. Entity ID, and this will give us at this stage it will give us an optional entity record. The expected option found bool. Okay. Filter map. I'm not sure if this one is the best thing to use here, but we will return the entity ID and the fact that it is okay or not. And another one. No, I'm overcomplicating. I'm overcomplicating for sure. I had to quit because I was getting tired, but it seems that the walking and fresh air did not fully recharge me. So what's the deal with those records? I'm feeling like this is the first algorithm I'm writing. So we want to get the first record where the entity record is vacant. Okay. Okay, let's go with the keys and find the first key, so the first entity ID for which first entity ID for which self.entity ID records get entity ID is sum. So this one will give me the first key, and the keys are in order, arbitrary order. Okay, I don't like that. Either way, I will find the first entity ID for which the index is not used. And then, and after we found our entity unused entity ID, so when we found our first unused entity ID, we want to get the entity record from there. So self.entity ID records dot get unused entity ID. Okay. And at this point we get an optional entity record. What's wrong with you? Entity ID. Okay. And this one is an entity record. So if we have a record So if we have an entity record, we want to treat the two cases. So entity record and the two cases occupied, and this is an index and this one is an index. So actually I don't care. Wait a second. And then get then filter. No. If this is occupied, we have nothing to do but to add a new one, a new column in our storage. If it is vacant, so here we go like this. If let entity record vacant index equal entity record. So if we have that, if we have a vacant index, what do we want to do? We want to register a new record in our records that is saying that for the key, and the key is our entity ID, this one, new entity ID. We create a mapping from our new entity ID to to an entity record that's occupied with the index. Yeah, okay. And one more thing we need to do. What's wrong with you? Consider. Okay. We also want to remove the mapping for which the entity record was vacant. So how do we do that? Unused entity ID. This is the ID we want. Actually, here we actually want to iterate over the key value pairs. So this is unused entity ID. That, and we don't go with the keys, we go with an iterator, and we go with entity ID, and entity record. Okay, and we can simplify this by saying we are looking for the key value pair that is some. Entity ID. What's not to like? Okay, let's simplify this a little bit. So we get an option, yada yada. Okay. So let entity record. So we return the first pair of entity ID and entity record where entity record okay. If let expected ball found option. Okay, some so we look for the first pair of entity ID and an entity record. And it may not exist at all. So First we go with the idea that the entity record exists. Let what do we have? Entity ID. And this is an old entity record. Let's name it like that. Old entity record. Old entity record. Old entity ID. And old entity. Do we need a record here? No, let's just ignore it for a bit, or not. No. Old entity record. So yes, if we have a vacant entity record, we insert the new pair of the new entity ID, and we mark the index, this index, as occupied, and we go self dot entity records dot remove, and we remove the old entity ID. Actually, let me do that first. Or we'll just leave it there. Okay, and I think we can get rid of that. Now, what if... Why are you there? Okay. If we don't have an old pair, an old unused pair, we just take the number of keys. So the number of keys is the number of entities, and the new entity ID index, okay? Index is the length of the keys, and we have new entity ID, and this is not an optional, it is an entity record of type occupied. Nice. And yes, we push at the end empty components, and we return this new entity ID. Nice. When we remove an entity, now it should be quite straightforward. So entity index, we look for our entity index in our entity records, and because we are mapping entity IDs to entity records, entities ID to entity records, we just go and look for the entity ID we get as an input parameter to the function. And this entity index, well, this entity record might exist or not. We care if the entity record so we care if the entity record is of type entity record occupied. What's wrong with you? Option. Okay. So then with this index we go over each bucket we go over each bucket and we want to okay, we go over each bucket and we set not set uninitialize no bucket so we have this push none. So we might need to add another function to our component bucket trait. Bucket dot remove component. Yes, that's one. The remove component at index. Okay. So we remove the components. So we basically, yes, we set all of this to none. And then from our entity ID records, we remove entity ID we got as a parameter here. And let's implement this one. First of all, we need to define it here in the trait mutable reference to self and an index, okay, and that's that. And of course, let's implement the missing functions, and for this one we go self dot remove dot get mutable. Okay, our index. So if at some component No. So first of all, we are looking for the index. If the index is out of bounds, it will not find the index, right? Yes. So if the index is out of bounds, it will not return anything, but we also want to check that we have some component here equals self, not self component, and here let me think a little bit, because let's read the documentation for getMut again. Returns a mutable reference to an element or subsize depending on the type of index, or none if the index is out of bounds. Yes, so I was correct about that. How did I do it here when I was initializing? So I was doing it like this. I was getting the bucket from the hash map, and I just went bucket entity ID. Okay. So coming back to our horses here. Here. Oh, we remove a component. So this getMut, it has a generic parameter I for index. Okay. No, I won't do it like that. I will do it self index. Okay, and I will just set it to none. And it is happy about it. Looks like it. Let me move that one there. So when we add a component, the capacity indeed is given by the ID records, but from keys. Okay. Bucket, entity ID, entry.insert. I think I'm missing something here. Okay, contains entity. Entity ID records dot keys dot contains. ID is some. Oh, come on. That's not too. Can't compare usize with usize. Okay. What else? Okay, here we are at our. Cannot borrow self-entity ID record as mutable because it is also borrowed as immutable. Nice. Okay. This is unused, right? I'm tempted to go with a mutable iterator here just to make it shut up. But can I do that? I need to okay, I'll ignore this create entity function for a little while, and I will focus on the others. Um, I don't get it. Why? Because yes, we are working with a reference there, but that one cannot be the reference. Okay. As the ref. Not good. I'm shooting myself in the foot here. Okay, let me restart the language server because I think this is a bit nuts. And I will also run this one. Okay. Indeed I need to rethink this one. Come on, finish your initialization. Come on. Okay. Okay then, let's go again over this. So we want the old entity record here. So this is the first record for which we have a vacant index. Oh, I think I have a simple fix. Cannot move out of shade reference. Data moved here. I don't know what's that. And with this one, oh, damn it. Damn it. Again, we want to find the first record for the first entity ID for which the entity record is vacant. Have self dot entity records dot we iterate over the key value pairs and we filter, do a filter map, and we filter on what? On the fact that we have the come on, we have the index and the record. Okay, we have the index and the record, and we care if let entity record and vacant. Okay, vacant. But this is not the index, this is the entity ID. Entity ID, and we have an index here that's equal with the record. So we are extracting the index from the record, and if this holds, we want to return a pair of entity ID and index. Sum of that. Okay. If maybe, oh, okay. Else none. And this is the old entity ID and the old entity record. Index, sorry, index. Okay, if that's not that. Oh, we have an iterator, okay. Filter map or find? Find map. Okay, find map. That's what we want. We want find map. And something is wrong here. I hate it. Entity old entity ID index. Okay. Old entity index. No, let's keep the name like that. And if we have some old entity ID and old entity index, entity. Okay, but here I don't want to have references, I want to have the real things. Okay, perfect. Now I have the real things, and this stuff should no longer be borrowed. Exactly this. And here we use the new entity ID and we record the old entity index as occupied. Perfect. And from entity ID we remove old entity ID. Nice. And if we don't have some place in our storage which we can reuse, we'll just go like this. We create a new entity index from the number of entities. Yeah, that. What else? Entity removal. With entity removal, what do we have here? Immutable borrow, and here we are mutably borrowing it. Entry. Yeah. Let's get the entry. And with this entry, what we do with this entry? With this entry, let's move that down a little bit. So we have this entry that represents key value pair. So if the entity record, if the entry, oh come on, entry, not entity, entry, oh come on, I feel, yeah, this one, entry occupied. So entry if we have no. Let's ignore what we had previously here. So when we remove an entity, we want to remove the components. So we do this for, as it's not physical removal, we just set them to none. And we do that with for bucket in components, and I will rename this to component buckets. And buckets, and for each bucket we remove the component at index, and we need that index. And we get that index by querying the hash map, the records. So let index equal, let's take one from this experience. Self yada yada, find map, and occupying. Occupied entity ID index, and I care about the index here. This is entity ID index, entity ID index. If we have something on those lines, entity ID and entity index. If we have this, we proceed with the removal. Entity ID, entity index, this is entity index. Okay, and after we remove the components, we also go ahead and do self.records remove, and we remove the entity ID. Well, we don't remove it. We don't remove it, but we set the entity record as vacant. So get mute entity ID. So if we have some entity record equal with that stuff, we want to set entity record to entity record vacant, and the index for the entity, so this one. Okay, I think something is wrong here. Okay, let's run the tests. Okay. We have tests failing, and we also have some coding style issues. This one, remove entity. Can remove existing entity. It fails because we actually don't return what we need here. Or this ain't nice. If entity ID equals entity ID and that one. Okay. I need to rewrite this filtering. So we want let's comment this, that too, and just get our entity ID. Okay, and this is an optional. Okay. At this stage, if I do this, if let's some entity index, this is entity record, entity record. Type option cannot be dereferenced. Don't you say? Okay, so if we have an entity index, actually this is entity record occupied. Okay, let's see. Can remove entity and attached components. Let's concentrate on this test. Cargo test. Okay, and the test name is this one. Contains entity, so line 269. Remove entity and contains entity is looking in the record keys, which is correct. That makes me think that on entity removal we don't do something okay. So let's read it again. So we extract our entity record from our hash map. We have our entity index. Okay, we have our entity index. Oh yes, because we are just marking it as vacant. But what we actually need is this one. Where are you? When we check, we are actually looking for the not that, but we are looking in our records, in our entity records, and we get entity ID, okay. So, and no, and then so after we've got our entity record, we check that actually we do it here. If let's some entity record vacant, occupied. If it is occupied, it's some index we don't really care about at this point. Return true, otherwise we return false. And our test passes, so let's run the full suite of tests. And we have a problem with our can reuse storage space from delete yada yada test. And we have an index out of bounds. Okay, we'll take care of that. But first, let's fix this coding style issue. So 137. If letters expression looks like matches macro. Okay. So let's do what they propose. Okay. We delete that. And we add that. And we put that here. And the comma there. Matches. Okay, we fixed the coding style. Now let's fix that use case. Let's concentrate on this one. So we have an index out of bounds. We have an index out of bounds on line 107. 107. Here. Here we have... okay. Get the given keys corresponding entry in the map for in-place manipulation. Ah, yes, I think I know what's going on. What happens if the key is not there in the hash table? So we can do here for insect. So let's take this out of that. So the capacity is the entity records keys. Okay, so let's move this one up there to the capacity, and here if the entry is vacant, for some reason I do that. Otherwise we'll also do this here. Default value is that. Ooh, this is ugly. Or insect. Instructor value is in the entry by inserting the default if empty. And returns a mutable. Okay, let's rewrite it in another way. If let's that one. Okay, and yes, this is not returning to me an entry, it's returning a mutable reference, and I don't want that. And the key is the entity ID. No. So when we add a component, we get the index from the records. Is not a bucket, but yeah, let's bury it. So this is the entity record. So we have the entity record of this entity ID. And if we have some entity, actually entity record. So we check if we have an entity record of type occupied, that gives us an index. And this one is entity record. Then with that index, if we have the index, we also want to get the bucket. So like bucket equals of dot components buckets dot get mutable. This is the type ID, and that's basically it. No, it's not that. Here we do an if, let's sum bucket plus bucket, and only after that we do this magic. Now what's wrong here? Cannot index into a value of type. Of course you can't, because you first and then bucket we do bucket dot any mutable, and then again we do the downcast. Not as mute as any mute, and down okay, that goes away. Downcast mutable of type K. Okay, that's, and this is not entity ID but index. Oh come on, cannot index into a value of type option. What? Okay, vector of type T. Cannot index up. Okay, we need to get rid of that sum. And now we are getting closer. The type D cannot be indexed by mute size. Is not implemented for. Okay. That one. Mismatch types. Okay. Option null here. And yay. Yay or nay? Ooh, nay. Okay, the section failed. So we no longer have that index out of bounds. Let's fix the coding style. 103. 103 here. What they are telling us? And then they say to use self component buckets get mute. So self component buckets get mute map. Okay. The coding style is done. And we have a section failure at line 329. 329. Ah, yes, because those actually have to be entity force. Because if you remember here, for entity 4 we are checking that we only have the F32. Only this one. Okay. Now we have an index out of bounds. The length is 3, but the index is 3. 149. 149. Here. Entity ID. Well, no, not entity ID. Not entity ID, my friend. We get the bucket for the type ID. Then we downcast the bucket. And then if let records, entity record occupied index equals with self that records ID records get, and we get based on the entity ID we get as a parameter, and if we have that what do we do? Okay, we need to wrap this in some. Okay, if that's the case, we go to our bucket at index and we check if is What? Otherwise, return that. So what's wrong here? Index. Ah, yes. And that. Oh, come on. Line 300. So now we got a crash at line 300 component. The function we just modified. So why did you crash? It panicked because of this one, for sure. For sure because of this one. So let's do a print and say index equals that of index target. Okay, and something else. Let's go like this. This is for entity 4, entity 3, and entity 1. Okay, let's try this and see what we get. So for the first entity, the index is 0, which is okay. Then for entity 3, index is 2, which is okay. Then for entity number 4, we have index 1. So this one executes okay, this one executes okay, and hell breaks loose for this one. So let's comment those two for a bit. Let's try that. Entity 4. Let's see what we get. Wait a second. Let's do the same for all of them. This is entity 1, entity 1, entity 3, entity 3. So here we will get the actual entity ID, and in here we will get the actual index. Let's just put like that. So let's try again. So this is okay, this is okay, yes, it's okay. Then for entity 4, the ID. The ID, it's okay. The index is also okay, but it failed now with the fact that let's work the code. So we get a value of 3 here. We do the type ID stuff, then we get the bucket based on the type ID. Okay, let me try to simplify this a little bit. Okay, to simplify this, so we get that we do let bucket equals that, and then or map. Let's go with map, or Clippy will bother us. Bucket. Okay, so that, and then we do the downcast stuff, and indeed we will use map. Map. Oh, come on. Map. Okay, and just a single if here, single bracket there, bucket. mm. uh, and then okay, we get our bucket, and we check to see that for the entity ID we have an occupied index. Actually, you know what, I will also print this here. Print what's this? The record equals something. Okay, that and save. And okay, record is not implementing debug, so let's implement debug for it. It checks out, those are occupied. Occupied. This is about the index, okay. That one is about the index. So we get the entity ID. We get the bucket based on the type ID. And with this bucket, we get the index inside the bucket. Also print this stuff. Okay, just go away. Oh, come on. Who's not implementing debug T? T is not implementing debug. Oh, come on. Wait a second. I want to print here the entire hash map if I might get around to. So print line, print new, oh come on, print new line that, and we have this of self dot components. Oh, component buckets. Okay. So dynamic trait is not implementing debug. Nice. So let's require the debug trait. Debug. Okay, let's check that out. Okay, let's run again. Let's try something. Instead of let's comment those because they are working. I don't get why this is not working. So when I create the fourth entity, oh, I'm so oh my bad, and I wasted so much time. So here when I'm creating the entity, the fourth entity, I wanted to add the load 32. Up and up, and those two, up, save, and check. Nice. Stupid test. Now let's check all the print lines. Okay. This goes away, this goes away, this goes away. Next. goes away, next, goes away and goes away. Okay, and now we are done. Now I'm confident that our reuse of the empty columns in our storage is done well. So let's go ahead and finally stage everything. I thought I deleted to stage everything, and so add and remove plain data. Okay. When an entity is removed, its components will be removed to actually set to none in the component buckets. Okay, next, when we create a new entity, we try to reuse the storage left unused after we removed an older entity. Okay, I created a stash. I don't want that, so I want to pop the stash to stage everything and commit. Okay, and now let's take a look at this user story. Yes, we covered all of this. Okay, perfect. And retrieving an entity. Okay, this is fast, so let's go and do it. We start as usual with some tests. The first test can the first thing we will do can read component data. Okay, and as usual, let's have this here. Okay, we need only one entity. We will deal with only one component entity, and we want to have this letter component equal universe dot get component of type usize. Okay, that and that. Okay, and here what I want to assert that actually assert equals that the type ID of, and here let's hope I can do this, reference usize is the same as the, oh come on, I can't get the type ID of a variable, so we scratch that section. We just assert equals that the component So the value of the component is equal with 0. Why 0? Because we have a new size and the default value of u size is 0. And the other test, it's similar, can modify component data. After we create the component, we want to get a mutable reference to the component. Okay, we will set the new value to 1, and then we assert that then we read the value again through a const reference or shared reference, and we assert that it is equal to 1. So let's go and implement those getters. Let's put them here. Public function get component with this. Okay, for this we want const reference to self, and we want to give back a reference to, we want to give an optional reference to an optional, yes, because we might not have that component set for an entity, and of course we want entity ID as a parameter there. So an optional reference to T, and similarly for the mutable variant, mutable, and a mutable reference to T. Now let's do some things here. First, we assert that we have I don't know exactly how to put it, like that. Expected type use size found. Okay, I agree with you. Okay, now here if let's component equal component, and we go like that. Sorry. And wrap. And yes, of course, we want to give the entity as a parameter to those functions. Okay, save. Let's go and take care of the implementation. So let entity record self dot entity records get entity ID. So if let's entity yes, some entity record, if it is occupied, sorry, index. So if this one entity record, this entity record is occupied, we want to go there and return that optional reference. So return self dot bucket. Okay, we need to get the bucket now. So about the bucket, let's steal this from here. Like that. And also let's steal this line. Okay. Now with our bucket. What do we want to do with our bucket? Our bucket, we want to return that. And I think we get in a hell of a mess with lifetimes pretty soon. What's going on here? The type option T cannot. Okay, that. Expected reference type T. Okay, we are getting closer. We are getting closer to what we want. So mismatch type, expected option T, but got an optional reference to option T. sref. Okay. It's no good. I want to get here a component as ref. So we can obtain an option of reference T, exactly what we want here. And we want to return this component. Nice. And we copy paste everything from here, we dump it here, and we go ahead and put mutable stuff where we are expected to put it. Mutable, don't cast mutable. Here we have a mutable. Let's get mute as mute. Yes. So let's try it out. Yoo-hoo! Perfect. That's everything we had to do to get a basic implementation of the entity component system. Please, if you want to get a better idea about the memory layout, just rewind either here in this second part or on the first part of the entity component system adventure. I didn't find the word. So with that in mind, thank you. So rewind to the sketches for the memory layout. If you review that again and things are not clear, please let me know in the comments down below. Thank you again for watching. Please like, subscribe and click on the notification bell. Until next time, bye bye.